Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI MStat 2017, problem number 2 from the PSB section. The problem says that let if mapping from R to R be an infinity differentiable function, and suppose that for some n greater than equals 1, f of 1 equals to f of 0 equals to f1 at 0, f equals to f2 at 0, and so on equals to at fn at 0 is 0. Where if this notation denotes the kth derivative of f, where k is some positive integer. Prove that there exists x in the open interval 0 1 such that if n plus 1 of x, this thing, is 0. That means prove that there exists some real number x between the endpoint 0 and 1 such that the n plus 1th derivative of f at the point x is 0. So since the function is infinitely differentiable, therefore it is continuous at every real number, right? It's continuous. So let us consider this particular interval, closed interval 0 1. So obviously it's given that f of 0 and f of 1 are both 0, right? F of 1 and f of 0 are both 0. And obviously the function is continuous in the closed interval 0 1 and differentiable in the open interval 0 1. Therefore, by the Rolle's mean value theorem, there exists a real number xi naught in this open interval 0 1 such that f prime of xi naught is 0. That means the first derivative of f at the point xi naught is 0. This is by the Rolle's mean value theorem. In short, by RMVT. Let us call RMVT. So by RMVT, there exists some xi naught in this open interval such that f1 of xi naught is 0, right? Again, let us consider this interval 0, xi naught, which is obviously a subset of the original interval 0, 1. This interval. Now again, consider this function f1 of x. That means the first derivative of x. Consider this function, not the original f, but the first derivative of f. This function also satisfies the conditions of RMVT. Why? Because if 1 of 0, let us consider the value of this function, this f1 at the endpoint. F1 of 0 is 0, as it is given in the question. This f1 of 0 is 0, 0. And just by the previous thing we did, we proved that if xi naught, if 1 of xi naught is also 0 by the RMVT. We just did this. So that means both the function, the function f1, this f1 is 0 at both of the endpoints, and also it satisfies the other conditions of continuity and differentiability, because again it's infinitely differentiable. So this f1 is also differentiable and continuous. So again it satisfies the RMVT. Therefore there exists a xi1 in this closed interval 0, xi naught such that if 2 of xi1 is 0, that means the derivative of this derivative, this first derivative, that means the second derivative of the original function, if 2 of xi1 is 0, right? Now this xi1 is less than xi naught, obviously, as you can see, and greater than 0. This lies between 0 and xi naught. Again, by considering this 0, xi1, which is even a smaller interval, which is a subset of this interval 0, xi naught, by Rolle's mean value theorem, there exists some xi2 in between this 0 and xi1 such that f3 of xi2 is 0. That means we are actually, what we are doing here is, first we are considering the interval 0 1, this interval, and it satisfies the conditions of RMVT, and therefore there exists some point at which the first derivative of the function at that point is 0 by the conclusion of RMVT. Now it's given that if the all the derivatives of the function at the point 0 is also 0, f1 of 0, f2 of 0, f3 of 0, up to fn of 0 is also 0. So we are going to use this fact. We are going to use this fact and use the help of RMVT. So as I said, as we just proved that there is a xi naught in between 0 1. Again, there exists some xi1 in between 0 and xi naught. This xi1 in between 0 and xi naught. Again, there exists some xi2 in between 0 and xi1. So by continuing this process, we are going to arrive at some stage where the function fn, that means the nth derivative of f, fn of x, also satisfies the conditions of Rolle's theorem, right? On the closed interval 0, xi n minus 1. We are going to get a sequence xi1, xi0, xi1, xi2, xi2, xi3, and so on up to xi n minus 1. And there, by the conclusion of the Rolle's theorem, we have there exists some xi n in between 0 and xi n minus 1 such that f n plus 1 That means the n plus 1th derivative of f at the point xi n is 0. This xi n actually belongs to 0 comma xi n minus 1, and hence is obviously belongs to the open interval 0 1. That means we have actually found out a point in this open interval 0 1, which is xi n, such that the n plus 1th derivative of the function at this point is 0. This is the answer. This is the proof. It's a very easy proof. It just needed to know the Rolle's mean value theorem, and that's it. Nothing else. It's a very easy problem, right? So there you have it, the solution to this problem. See you till next time. Bye.